Okay, to start with, just checking on how you simplified each of these. For this one, you should have come up with 12x squared minus 15x. For this one, you should have come up with x squared, and then there's a minus 5x and a plus 3x, and I'm just going to put them together right away, minus 2x. You've got to be able to do that kind of stuff in your head. Then minus 15. For this next one, I'm going to know that it starts with x squared, but that the outside and the inside are going to cancel because they're opposites. And so then it's just the lasts, which makes that part, which is minus 49. And last but not least, that is not x squared plus 9. If you said that, please remember, it's one of my top 20s, because it's a really common mistake. You got to multiply it all the way out, including that middle term of a 3x and a negative, or positive 3x and another positive 3x, x squared plus 6x plus 9. Okay. About all of those, every single one of those was a quadratic. And a lot of you guys only think of this kind as a quadratic, but the other ones are quadratics too. So what makes you quadratic? If you have a squared. All right, if I'm going to just go to the side for a second and remind you, your very first thing you learned when you were a kid, like a little kid, was just what numbers were. So if you just had y equals 5, they were saying, okay, we're going to have this thing y, we're going to use that and call that 5. I'm sure the first time you heard that, you were like, what the heck? It's a 5. Why would we call it a y? Okay, but then you moved up to saying y equals 5x. And that meant that we could have different combos that could work. Like 5 times, let's say that's 2, and this could be 10. All right. Then now you're moved up to where you have 5x squared in your problem. And can also have other things like 3x and another 5 or whatever. What's special about these? Well, basically the shape is different. If you look at the graph of y equals 5, plain old-fashioned y equals 5, that was a straight line. Y equals 5x was also a straight line, but it had a slope to it. Instead of being just a flat straight line, now all of a sudden it was a sloped straight line. And now this kind, a parabola, is a curved line. No more just a tilted straight line. So they're getting more complex. What do you think happens next? The next kind of functions we move into after squared, what do you think? Cubed. So what does a cubed function look like? Let's say I had 3x to the third plus 2x squared plus x plus 9. Well, that, instead of just being a straight line or a tilted line or a curved line, now it's got waves in it, like that. And every other function after that is just going to have more and more waves, pretty much. All right. So that's kind of the big picture of where we are. Now, what was the special? Let's look on to, that's a pretty picture. How many guys have had a chance to see the Golden Gate Bridge? A few of you. It's really pretty. It was a problem, though, for suicides. They had a lot of people go on the Golden Gate Bridge and jump. And they have telephones. I remember, what's one of the things I remember the most about that bridge is walking across it. There's a telephone like every 30 feet, and it says something like call if you're in danger, if you're in trouble, because they want to try to talk you out of killing yourself on that bridge. One guy who jumped off the bridge tried to kill himself, but survived it. And first of all, you might think everybody would. Don't you just land in the ocean? The problem is that when you hit the water traveling that fast, it's like you hitting a wall at 80 miles an hour. Okay? Like if you hit that concrete wall right there at 80 miles an hour. And then the worst part is, now of course you're all, knocked silly, like, oh my gosh, you're hurt bad, and then you're in the water. Okay, so it's pretty likely you're not going to survive. But this guy survived. And he has now led a campaign to put up these, like a rope, like a nets underneath the bridge, so that basically if you jump off, you'll just end up in a net. Because there's too many people that have killed themselves on that bridge. They decided it's just not worth it. We're going to put up some nets underneath it, You won't even be able to see them unless you're standing over and you're looking straight down. So I don't think it'll be like an eyesore or anything, but it should save lives. So, anyway, interesting factoid about that bridge. Why is that bridge on this? Because if you look close, you'll see parabolas in it. Look close at the bridge. Do you see parabolas in there? All right. Now, technically, I hate to burst the bubble of the person who posted this thing, but that's not technically a parabola. It's a catenary curve. But that's something you're not even going to learn until college, but it's very, very, very similar to a parabola, and it looks a lot like a parabola. And you could fake it and make a parabola that looks like that. But anyway, now here's another one that's upside down. Those kind of gentle curves. Here's another one in the rope. But again, technically, catenary curves. You'll find that out more when you're older and smarter. Okay, let's go to this. These are the X-intercepts. They are the most important parts of the parabola. Why do they get to be special? Because they're called the solutions. Anything that's called the solutions is kind of important, right? They got 4 names: solutions, roots, zeros, and X-intercepts. So just to confuse kids, I think it'd be awesome on our next test if we had one question where it said find the roots, next question says find the zeros, next question says find the solutions, and then the last question says find the X-intercepts, and it could be the same exact question over and over and over again. So that also means that on the ACT test, you don't know which way they're going to ask it. They could ask you to find the roots, or the zeros, or the X-intercepts, or the solutions, and they would mean the same thing. All right. Next, this vertex spot, that's really important. And that little line that runs down the middle is called the axis of symmetry. The y-intercept is not as big of a deal on these. It's not called the solution. And I do want to remind you about some sayings we have about this. Finish this sentence for me. The x-intercept is where y equals 0, and the y-intercept is where x equals 0. Okay, good. So that'll serve you well. If you have a parabola, everybody write this one. Y equals negative 4.9 x squared plus 3x plus 7. If I want the x-intercept, I just got to put y equal to 0. Does that just instantly solve it for me? No. But then I use the quadratic what? Quadratic equation, quadratic formula. Okay? Usually we call it the quadratic formula. This is a quadratic equation. So we don't say the quadratic equation, we usually say the quadratic formula. Everything that's got a squared in it is a quadratic. Well, I shouldn't say that. If its biggest power is a squared, then it's the quadratic formula. Okay? It's a quadratic equation. But the quadratic formula, the big one, x equals negative b plus or minus square root, that one is the one that you're going to use whenever you set the y equal to 0. Okay, so that was to answer the x-intercept, is where y equals 0. Now, take that same equation. What do you think we would do to find the y-intercept? Put x equal to 0. Just put a 0 here and a 0 here. This all cancels, and it's y equals 7. That's quick. So the x-intercept and y-intercept are two things that are really easy to find. All right. Then there's the axis of symmetry. Some kids call it the axis of symmetry because it's an x equals line. Back to this thing. See this right here? That's at x equals 1. How do I know? Because I look down here. It's the axis of symmetry. It's dumb, but it's stuck in my head. Kid just said it once, and I thought, that's a pretty good name for it. Now, there's an equation for that. Would everybody please write this down? X equals, in fact, I said it the other day, and I know somebody's in here is going to remember it. The equation for the vertex is the same as the equation for the axis of symmetry, or at least it starts the same. Do you remember me telling you it was the beginning and the end of the quadratic formula? Okay, I'm feeling like nobody's ever heard this before, so maybe I didn't say it. Negative b over 2a. How many of you feel like you remember that now that I said it? Okay, maybe 1, 2 people. Okay, negative b over 2a. Write that one down. That's one of the big formulas for this unit. My goal for today is to kind of like big picture talk about everything about quadratics, try to bring back all back. You had it before, you really did. This is Algebra 2. You took Algebra 1. Quadratics were in it. Now, I know you took a whole year off last year when you took geometry. Not saying you didn't do anything. I'm just saying you probably didn't touch quadratics at all. And that's one of the flaws in our math system. I'm trying to fix it with the top 20. I'm going to have that top 20 type thing, except it's going to be the first 20. That's going to be in geometry. That'll remind people about, like, don't forget your algebra during geometry. That way, when you come here, I can focus on, like, let's get you the top 20, which is, like, the higher level stuff that we actually need for this class. All right, so negative b over 2a. Notice it's the beginning and the end of the quadratic formula. Would you please take a second and write out the quadratic formula, because that's what gives you this. If you want to sing along. X equals negative b plus or minus square root of, what's next? B squared minus 4ac all over 2a. Good. Notice this part, the beginning and the end of it, that tells you the axis of symmetry. Negative b over 2a. What are these a's, b's, and c's you're talking about, Mr. Server? Let's go back here. See if I can... No, I can't. I was going to try to drag that writing off of my... I'm going to rewrite it just so that I can see the numbers easier. That's A, that's B, that's C. When you've written it in standard form, the A is the first number, the B is the second number, C is the third number. Does that ring a bell? Okay. So, what if I wanted the vertex or the axis of symmetry? They're the same equation. X equals negative b over 2a. That's negative 3 over 2 times negative 4.9. That's an icky number because it's a real world kind of number, because this is the formula we use for a ball that's been thrown. Negative 4.9x squared minus or plus 3x plus 7. That's like this. That's like a ball that got thrown from 7 feet high to start with. Y-intercept, that ring a bell? And the ball goes up, reaches its highest point, then that's the time when it hits the ground. So this doesn't really happen unless you threw it over mud and it like sunk into the mud, okay? All right, so that formula, negative b over 2a, that formula, I'm gonna just put a QF for quadratic formula. And this one right here, that's the y-intercept, so x equals 0. There, just told you everything. Seriously? That's almost everything for this whole unit. And this unit is like a week and a half long. Just trying to give you the big picture. You've seen this stuff before, and I know you may have forgotten some of these formulas, but I'm doing pre-teaching right now, because that'll help you in the long run. This will all make more sense. I don't want you to just teach one little thing each day and not see the big picture. All right. So last thing I want to talk about is in that quadratic formula, this guy. Remember how we called out the beginning and the end of it, and this was the axis of symmetry? And the start of the vertex? Why did I say the start of the vertex? Because it's only the x. It's only the x of the vertex. Do you get a vertex is 2 spots? It's an x and a y. You know, if I found this vertex right here and I just said, I found it, the x is 1. Well, it also would be nice to know what the y is. But all you have to do for that is stick the x number in the equation. So the x is the big deal. Well, what's this? This is like the last thing for this unit. The b squared minus 4ac part. Guys, remember there's a name for it. It starts with a D. Dis something, yes. Dis what? Distance, no. The discriminant. I'm pretty sure you learned this one, but you might not have. This is called the discriminant. D-I-S-C-R-I-M-I-N-A-N-T. That is called the discriminant. Would you agree that if it's negative, we know it doesn't have real solutions? If it's positive, then that's just a normal square root. Well, everything's either negative or positive, isn't it? Wait a minute. There's one more option. It's either negative or positive or what? Or 0. And if it's 0, then think about it. This whole thing would disappear, and the plus minus would disappear because plus and minus 0 don't really do anything. And then you're left with this formula again, which was what? That was the vertex. So what does it tell you if the discriminant is 0? That this is just going to all go away, and you'll be left with the vertex. There, I've just taught you the whole unit. Now, I know you didn't understand all of that, but I really feel like it's kind of like giving you a map of the whole area and saying, okay, this is where we're going to build our camp. And you got to know that big picture, like we're right by a mountain and the ocean's over here and there's a river that's going to run between us and the ocean, and like big picture. Now we'll zoom in and get good at each part. Okay? All right, so let's go look at this. There's 3 ways you could write equations that are quadratics. One is vertex form, and I'd like to give you an example. Y equals 2 parentheses x minus 3 squared plus 5. Do you get that's a parabola that has been, you remember this unit? Moved to the right 3 stretched factor of what? 2, and then the last thing is this is moved, what's that? Up 5. So don't forget, those rules still apply. All right, when it's like this, y equals 2x squared plus 12x plus 5, for instance, that one's not as good at telling me where that parabola is. Oh, it's been moved to the right and left and all that stuff. The only thing that you can tell is if it's stretched. Stretch factor at 2. You can also tell A, B, and C really easily, so you can figure out the quadratic formula using those, which tells you the roots. And I can see the y-intercept, because x is 0, would cancel off these 2 things. So what's general form good for? I just said it, but I'll say it again. It's good for finding the y-intercept, the roots, because the roots come from the quadratic formula. I often will, during this unit, call it the quadratic formula, because quadratics have roots, and that's what the quadratic formula does is it finds the roots. And it's also good, well, I guess I'm going to call it A, B, and C. It tells you A, B, and C. That's what it's good for. Big surprise, the vertex form is good for knowing what the vertex is. And by the way, in case you hadn't figured it out yet, the vertex on this one is 3, 5. Because you know you'd move over 3 and up 5? Doesn't that make sense? Now, why isn't it negative 3? You don't trust the stuff on the inside. And last is factored form. I'll give you an example. Y equals 2, parentheses, x minus 3, parentheses, x plus 7. And you know that I love factoring. In fact, it's my favorite thing. If you can factor it, you should. So why do you factor it? Well, because then, let me show you how factored form is so handy. What if I want the x-intercepts? I set y equal to 0, and then I know them right away. Boom, boom. I know the x-intercepts. Can you tell? What's the x-intercept for that part? Plus 3. What's the x-intercept for that part? Minus 7. See how I know it's plus 3 and minus 7. And I know it's a right side up parabola, so I know it looks like that. It helps you so much when it's in factored form. So what's factored form good at? It tells you the roots. It's way quicker too. The other one will give you the roots, but you got to use the quadratic formula to get them. If it's in factored form, you just know the roots right away. Boom. There they are, those 2 numbers. The things that make it equal 0. So what's factored form good at? Gives you the roots. What's vertex form good at? It gives you the vertex. And what's general form good at? It gives you the general. No. Vertex and factored are pretty obvious, but general form, the biggest thing is it tells you the y-intercept really clean and easy, and it will tell you the roots because it gives you A, B, and C. Okay. So here's a summary of everything I just told you, but I believe if you just read something like this, you're just going to gloss over it. So I tried to show you why. They did bring up one other good point. For general form, it is easy to put in a graphing calculator if it's in y equals form, because you know how you have a y equals button? So as long as you have y equals, those numbers are easy to type into the calculator. Right. This is not too tough. That is called a maximum. What do you think the red one has? A minimum. What do you think this blue one on the end has? A maximum. All right, so how do we tell if it has a maximum or a minimum? Well, based on if the parabola was one way, you have a minimum, and if the parabola is the other way, you have a maximum. So let me just ask you this. If I just give you one, 6x squared plus 3x plus 4. I can tell by just looking at that whether this is going to have a max or a min. Can you tell? Well, is it a U shape or a mountain shape? The one I have written on the board, is that a U shape or a mountain shape? U shape. That is going to be a U shape because it hasn't been flipped over. I don't like memorizing these rules because you'll never remember them. You'll never memorize them. But you should be able to just look at that and go, oh yeah, that's a U shape. I don't know exactly where it is. I do know its y-intercept is 4. So I got to go up like 4. And that'd be, could look like that. Well, it's definitely a U shape, so it has a minimum. What if it had a negative in front? Remember how that flips it over? And it would have a y-intercept of 4? Do you get that that means this one would have a maximum? Don't try to memorize. If it's negative in front, it has a maximum. Don't do that, because you'll just forget it. But if you can just visualize whether it's upside down or right side up parabola, that's how you tell if it has a max or a min. Okay, next. How do we get the equation of the axis of symmetry? Remember I called it the dumb name and it might have stuck in some of your heads. Don't think of it as the axis of symmetry. Think of it as the axis of symmetry. X equals, what was that formula again? Come on.
Negative b over 2a.
Negative b over 2a. Very good. That's how you tell the equation of the axis of symmetry. All right. If you're looking at a picture, you can just go, well, there it is. See, it runs right down the middle. But if they give you the equation, it's a lot harder. You just got to use this formula. Now remember, I've kind of said that the vertex is the same thing. It's because the vertex will be on that line every time. If you draw that line in, the vertex is on it. You draw that line in, the vertex is on it. The vertex has got 2 spots, though, and the axis of symmetry is just an x equals thing. All right. How do we identify the axis intercepts of a quadratic? That's a really complicated way to say the x-intercept and the y-intercept. Well, if you're looking at a picture, you're going to go, duh, that's the y-intercept and that's the x-intercept. That's not hard. Where does it touch the y-axis? Ooh, wait a minute, this one doesn't touch the x-axis. Yeah, that's okay. That means it doesn't have real roots, which means it's got to be the square root of a negative going on. That's why this guy doesn't touch, because when you did its quadratic formula, you'd have a square root of a negative inside. And this guy touches. It's got 2. Well, the x-intercept is where y is 0, and finish the other sentence. The y-intercept is where x equals 0. That's the key on that slide. All right. Now, which form is each one of these in? I feel like this is the Star Wars movie, It's a Trap. That is not in any form. It looked kind of like factored form, didn't it? But except if you throw another number after it, it's not factored form anymore. Would you please draw an arrow to where these should go? I'm okay with you just being a little lazy and going, okay, I think this one's general form. It's not, by the way. So I'll draw an arrow here. Draw an arrow to where each one goes. In a minute, I'll tell you if you've got them straight. Factored form kind of looks like this, but it's not. General form generally is all multiplied out. And vertex form is the one where you've got something like this. That's vertex form because you can find the vertex from it. It'll have something squared. All the other ones don't have squared. Well, no, I shouldn't say it that way. I'll tell you better how to find vertex form in a moment. But for right now, I told you this is a none. I didn't want you to start with a confusing one. Move each one into the right form. Some are in vertex, some are in general, some are in factored. I'm going to pause for a second while you give that a try. Okay, here's where each one goes. This one is vertex form. This one, general form. This one, may look strange, but it's general form. It's definitely not factored, doesn't have two parentheses. What if it's got one parenthesis? That's usually vertex form. What if it's multiplied all the way out? Generally, that's general form. How about this one? It's multiplied all the way out. It just looks a little strange, but it's general form. If it's been multiplied all the way out, it's general form. This one's got one parenthesis. What's that a clue? Vertex. This has got two sets of parentheses and nothing on the outside. That's your first factored form. This one, it doesn't have a squared in it. So that was a trick question. It is not a quadratic. You might have thought it's general form. That would have been a good guess, but it's not a quadratic. So I don't know. It all depends on how nasty the teacher was. You could say, well, it said the quadratic equations. So that's not a quadratic. But if you're going to say what form it is, you could say it is in y equals mx plus b form, but it's not a quadratic. Okay, this next one, that's vertex form. I know it doesn't seem like vertex form, but if I put a, let me show you something. If I put a plus 0 right here, it might help you to see that that's in vertex form. It's just got one parenthesis, and then it's got a plus 0. But this is the only one that qualifies under two forms. Did somebody else think it was a different form? Yes, sir. And you are also correct. It's vertex form and it's factored form at the same time. It's kind of a trick question. Why? Because if you broke it up into its two parts, it's x plus 2 and x plus 2. So that's factored form and it's vertex form. This is the only one that I would call a double. It fits into both categories. It's like the really, really rare professional baseball player who's also a professional football player. It's super hard to do, but I mean, it's hard enough to get to be a professional in either one of them. To be both. Is there anybody right now who's able to pull that off, like currently? There's some guys in the past who have.
He's the quarterback for.
What do you think? Say it.
Luke Tollefson, he's the quarterback for football and he plays lacrosse.
There you go.
He's like
Football and lacrosse, did you say?
No, he played on like the.
You guys are talking about different people, but.
He played for the Athletics, and then he was also playing college football.
So football and baseball.
Yeah.
Gotcha. Well, there was one guy. Was it Bo Jackson? Was he one of the ones that made it in both?
Yeah.
Michael Jordan played around with it a little bit because he played some minor league baseball, I think, but I don't think he actually got. Anyway. Okay, back to this. That's factored form. What's factored form good at again? Tells me the roots. X equals 1 is a root, and a 0, and an x-intercept, and a solution. So this tells you 4 things. Factored form is really good. That's why I say if you can factor it, you should. Those two answers are the x-intercepts, they're the roots, they're the zeros, as in they make the equation equal 0. All right, that is enough. Now, you have learned everything you would need to be able to know to be able to do the homework for tonight. So now, for the rest of the hour, you have time to work on your homework. You also can take a look at your tests that you took. If you have questions about, like, why did I get this wrong, you can come up and ask me. If you want to start corrections, you can, but do it on a separate sheet of paper. Remember to never write on your original test. You just take a separate sheet of paper and fix anything you want to fix. You don't have to do your corrections right now. You can come in the morning to do that. Last thought on that, if you want to come in to get extra help, the next day for us is tomorrow, Thursday. You can come in the morning, tomorrow morning if you want, or after school today or tomorrow. Okay, that's all I got for you for today.